we are going to talk about, okay, we're going to talk about NumPy. Okay.
Okay, sir.
So NumPy is a matrix-like data structure. Okay. So NumPy is a, how many have you done matrices?
I have done, sir.
Okay, data structure. So what it does is, okay, it creates a two-dimensional data set. Okay, so you will have row and column, right? So if I have values like 1, 2, 4, 4, 5, 3, 2, 1, 4, right? So this is an example of matrix.
Yeah.
Okay, how many rows does it have?
3.
Yes, so first we write rows. And how many columns it has?
3.
3.
3 by 3.
Okay. Yeah, so this is your row 1, row 2, or in Python we call it as row 0, right? Row 0, row 1, and row 2. This is your column 0, column 1, and column 2. So we have 3 rows and 3 columns. Okay? You get 9 values, right? So how do we define NumPy? How do we create NumPy? So to use NumPy, we have to say import NumPy. Okay. Now we'll be writing NumPy. Right? So it can be a little cumbersome. So you can just say import NumPy as NP. If you say import NumPy as NP, it's like giving it an alias. We are giving NP as alias to NumPy. So we don't have to type NumPy again and again. We can type NP.
Okay.
Okay. We can type NP and our work will be done. Okay. Okay. So let's create our first NumPy. So what we'll do is first we'll create a range of values. So I want to create 3 by 3 matrix. So if I want to create 3 by 3 matrix, how many values I need? So what I'll do is I'll create, okay, I'm just generating, a range of values. So when I say range 9, what all values will I get here?
Zero to 8, sir.
0 to 8.
Yeah.
Correct? Now I will reshape it. So this will be a linear, right? One dimensional.
Yes.
I'm going to reshape it into 2-dimensional or NumPy. So you say x equal to np dot reshape. It's not coming. Okay. Yeah, it came. It's slow. Reshape. And now I'm saying that reshape what? X. And into what format? 3 by 3 format. 3 comma.
Yeah.
So reshape will take 2 parameters. First is the value that you want to reshape, and second is the dimension in which you want to reshape. Okay, so you create 3 by 3 comma 3, and then you say print x. Okay, now x is our NumPy object. Okay, x is our NumPy object. So if you want to print the data type here, you say print type of x. Okay, before generating, and after generating, let's do the type of x. Okay, so see, before it is of type range, and
Okay.
after converting into NumPy, it is of type NumPy. Okay, ND means n-dimensional array, and n-dimensional, 3 by 3. Now, when you look at it, how does it look like? Right? So this is a list, isn't it?
Yes, sir.
This is a list. This is a list.
Yeah.
And entire thing is in a list. right?
But there are no commas in between
There
the
are no
elements.
commas, exactly. Okay.
Yes,
So
sir.
the point I'm trying to make here is, yes, there's no comma, so it is not a list of lists. It is NumPy.
Okay.
Okay. It is
Yes.
NumPy only. It is not list of list.
Okay.
We can convert list of list into NumPy. List of list will also be one dimensional only, right?
Yeah.
We can convert list of list into NumPy. Okay. We can convert various other things into NumPy. But yeah, this is how the NumPy would look like. If you want to know the shape of it, okay, so we have something called as shape. We'll tell you the size, dimension. Okay, print shape of the NumPy. Okay, you say x dot shape. Okay, first value is rows, second value is column, right? First value is row, second value is column. It says 3 by 3.
Okay.
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 How do we create list of list into NumPy? So let me create a, you can create a list. So I'm going to say y equal to, okay. Now let's add the values. 2, 3, 4, comma, 5, 6, 5, 6, 2, comma, 3, 7, 4. Okay.
Okay, sir.
So I created a list. Okay. Now I need to convert it into NP array.
Yeah.
Okay. I need to convert it into NP array. So I will say y equal to NP dot array, and you say y. Okay. Now you can print y. So we saw how to convert range into NumPy, and we are saying how to convert, okay, list of list into, okay. So this is how you can convert range. Okay. Now you want to, how do you read it? I want to read it.
Read in the sense print only, no, sir.
Yes. So I want to read portion of it.
Okay. Like first row and all.
Yes. How do we do that? I told you before also.
Okay, as we do for list, sir. Like print y of 0 or 1 or 2 like that.
Yes. Yes.
Okay.
So we use square bracket.
Yeah, yes, sir.
Okay. So let's say this y. I want to read y. Okay. So I will say print y. Okay. Now, okay, let's say I give 0. What will happen if I give 0?
First row will be displayed.
Right? Okay.
Yes, sir. Yeah.
First row is displayed. Okay. Now I give 0, comma 2.
First and the last one.
No. Okay.
1 second, sir. Of
I'm saying
last
row
element
0,
of the first row. Yeah.
row 0 and column 2.
4. Yeah, 4. Last element. Yes.
Right?
Okay, sir.
Oh, so yes, if you want first row, you will say like this. If you want specific element, you'll say like that. Right? I want second column. Then what will I do? Okay. If I put delete, it is giving error. How do I get only second column? You say colon. That means from starting till end, get me of second column. Okay. So you got okay. So 2, 3, 4, 5, 6, 2,
డిస్టర్బెన్స్ అవుతుంది క్లాస్ అర్థం కాదు
4, 2, 4. Right? So you get last column. Yes. Okay.
ఓకే సార్
So this is how you can do. You can access, okay, the elements.
ఓకే
Okay.
ఓకే
So now let's learn to add some dummy values. Dummy values to the NumPy object. Okay. So here something called as z equal to np dot zeros. Okay. And then you mention the size 4 by 4. So when you run this,
4
see?
rows with zeros yeah okay
Yeah, 4 by 4 is the size, and you get all zeros here.
what is that point sir
0.0 is creating a decimal value. Now we did not give the data type,
okay okay
right? We did not give the data type, so it created a float.
okay
Okay.
okay sir
Now, if you want, say ones, what shall we do? You write
np dot ones
ones. Okay.
okay sir
Now, say I want twos. So I'll say
Simply
here
twos.
full. Okay, full, and then you give whatever you want to give as second parameter.
Okay.
Okay. Yes.
Yes, sir.
So you get twos
So
here.
if we are specifying 1 or 2 or any particular number, then it will be printing in integer format, or else it will print in float format, sir.
Yes, default is float.
Okay.
right?
Okay, sir.
Then, okay. Then let's go and do some operations on matrices. Okay. Okay, I'm just thinking. So, what are the operations that you can think of in a matrix?
Finding out the determinant
Right.
delta.
Right.
And
So yes, so you can do the sum,
yeah,
difference,
inversion,
right?
and
Yes.
multiplication also, sir. Matrix multiplication.
Matrix multiplication also you can do it.
Yeah.
Of course. Okay.
Yes, sir.
What else?
Properties will also be applicable, like additive closure and all.
Yep.
Transposing.
Right. So let's go step by step first.
Okay, sir.
Okay.
Yes, sir.
Let's say let's first start with creating identity matrix. Okay. Okay. Mostly, see, you'll be using range. See, range will generate dummy values, right? So instead, you'll be using mostly creating a list of lists and then converting using NP array, right? And you know how to create list of lists. You can create list using input, using user interactive as well. Right? Once you do that, then you can perform other operations. Okay. So let's look at the properties of matrices first. So first we'll talk about what is identity matrix. What is identity matrix? What is identity matrix?
One zero zero one, like that, sir. Based on the size, all the diagonal elements will be 1 and the remaining elements will be 0.
All right. So we say diagonal elements. Okay.
Yeah.
So let's say I'll call it as identity matrix 1 equal to np dot identity. Okay. And I say three values. Okay. And print bm1. Okay, 1 0. Now, if you do not want it to be float, you can say d type equal to int. You'll get integer values here. So, see, this is called diagonal, main diagonal. So you know, it will have two diagonals, isn't it? When you
Yes,
go
sir.
back, this is one diagonal like this, and this is another diagonal. This is your forward slash, right? Kind of.
Yes, sir.
So this is not the main diagonal, okay?
Yeah.
This backward slash or left to right slash is called main diagonal. Okay, so the main diagonal will have 1 and rest everything will have 0. That's called identity matrix. Okay. Now let's perform matrix sum. So let's say I create X and Y. So this is your Y, and let's say this is your X. Okay. Okay. So this is our X and Y.
Yes, sir.
Now, if I say X plus Y, print X plus Y.
So
What will happen?
27th line, X equal to NP dot array of X, sir.
Yeah. Okay. Yeah. Why do we get 2, 2, 2, 2? Oh, I did not print Y, X, and Y, right? Okay. Okay. Let me do something like this. Okay. Print operation. And I'm going to print X, print Y. Okay, so this is your X.
Yeah.
510, 112,
304.
304. And Y is 234, 562, 374. So when you add, what happens when you add matrix? It will add the first member to the first member.
Yeah, corresponding elements will be added.
Right? So 5 plus 2, 7. 1 plus 3, 4. 0 plus 4.
7 4 4 6 7 4 6 7
8.
Okay. So yes, this is how you would print, right? Difficult to consider that. Then you do X minus Y. Okay. Then you do X into Y. Right? So 5 into 2, 10. 1 into 3, 3. 0 into 4, 0. 1 into 5, 5. 1 into 6, 6. 2 into 2, 4. 3 into 3, 9. 0 into whatever, 0. 4 into 4, 16. Okay, you can perform plus, minus, into. You can perform division as well. Okay.
Okay, sir.
5 by 2, 2.5. Okay, so this is normal operation, but matrix multiplication is not like this. Okay, matrix multiplication is little different.
Yes, sir.
Okay, matrix multiplication. So first of all, okay, so all these operations that we have done, plus, minus, into, division, here X and Y should have both should be, they should have same shape.
Yeah.
See, we write matrix singularly, plural form is matrices. Okay. So above operation, both matrices should have same shape. That means 2 by 2, 3 by 3, 4 by 3, 5 by 3. And I mean, whatever shape you give for first one, same shape, second one matrix should also have, second matrix should also have, otherwise you can't perform, it'll give you error. Okay. Now for matrix multiplication, okay. The first condition is this. So if the shape of first matrix is A by B, okay, if the shape of first matrix is A by B and second matrix is say M into N, okay, then this B and M should be same.
Yeah.
B should be equal to M. Okay, matrix multiplication. What we did was normal multiplication. That is not matrix multiplication. Matrix multiplication, your B and M have to be same. Your B and M have to be same. Only then you can perform matrix multiplication. And the output is going to be A into N.
Yeah.
Okay, so you can clearly see that A into B is not same as B into A. Okay, it will not be. So your matrix multiplication, okay, if you have a matrix 1 of size A into B and another matrix of M into N, then A, B and M should be equal. Okay. Condition. Okay, A into B, matrix multiplication, M into N, here, B should be equal to M. B should be equal to M, otherwise it's not possible. Okay.
Okay, sir.
So if I write, let me use same X and Y. Is it possible to perform matrix multiplication on this? Tell me yes or no.
X and Y, sir. Yeah.
X is 3 into 3.
Yeah. Y is
Y
also
3 into 3. Right? Yes. So inner it is the column of first matrix should be same as
row
of second matrix. Number of columns should be same as number of rows. Right? Number of rows of first matrix should be same as number of columns of first matrix should be same as number of rows of second matrix. And the resultant will be number of rows of first matrix into number of columns of second matrix. That's what that one line means.
Yes.
Okay. How to calculate? Okay. You can simply use matrix multiplication. So we use something called as matmul. Okay. I call Z. Z equal to X dot matmul. No. Sorry, not Z dot, okay. NP dot matmul. Okay. And you pass X comma Y. So when you pass X comma Y, X becomes the first matrix and Y becomes the second matrix. Okay. Now, when you Run it. Oh, I need to print, right? Okay. So the way it works is, let's create a simple 1 1 1 1 1 1 1 1 1 into 2 2 2 2 2 2 2 2 2 2. Okay. Just remember this shape, half T, or line, first straight line and then drop down 90 degree. Okay. So we have to go first row here and then column here. So resultant matrix, we know it is going to be 3 into 3, isn't it? Something will come here, 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 and here, here, here. What comes here? So first row into first column. First row, okay, we have to multiply with first column of second matrix. So you say 1 into 2, 2, plus 1 into 2, 2, plus 1 into 2. This becomes 6. Now, this is your second column, first row, isn't it? First row, second column. So first row, and now multiply with second column. Okay, depending upon whichever value you want to find, those things have to multiply. First row, first column. This is first row, second column. So first row is this from left side. Row is always from left side, and column is from right side, or second matrix. Okay. So 1 into 2, same thing. Okay, 1 into 2, 1 into 2, right? So you get 6 here. Now here, first row, third column. First row, third column, right? 6. This is second row, first column. So this is your second row, isn't it? And this is your first column. So 1 into 2, 1 into 2, 1 into 2. Similarly, you get 6, 6. Okay. So row into first matrix into column of second matrix. This is how you perform. Okay. Now coming back to our okay. So we have done math, right? Let's verify if it is correct or not. So let's take this value. Should it be 23 or not? So this is second row and second column.
Yeah.
Right. So this is second row, 1, 1, 2, and 3, 6, 7 is second column. So 1 into 3 is 3, plus 1 into 6 is 6, 9, plus
Correct only.
2 into 7, 14. 9 plus 14?
23.
Let's check if 28 is correct or not. This is third row, third column.
Yeah.
So third row is 304. Third column is 424. 3 into 4, 12. Plus 0 into 2, 0. 4 into 4, 16. 12 plus 16?
28.
Everybody clear? This is how we do. This is how we do matrix multiplication. Okay. This is what they are also teaching me in PhD. Okay. Of course, much more advanced matrices than this. Okay. Matrices are your foundation for machine learning. You may not realize it now because we are not getting into the development of the algorithms. We'll be focusing on using the applications, right, of machine learning. So if you get into that, then yes, this becomes important to know. Okay, so this is how you perform matrix multiplication. Now, what is determinant? how to calculate determinant. Okay. Determinant is one single number that represents a matrix. The determinant formula changes based on, for one dimension, 1 into 1, the number itself is determinant. For 2-dimensional, okay, you have to first multiply the numbers on the main diagonal, subtract the multiplication on the second diagonal. Okay, so if you have, let's say if 23, 14, 37, 28, if this is your 2 by 2 matrix, the answer will be 23 into 28 minus 37 into 14. Okay, that is determinant. Okay, so let's create a matrix. I'm going to create matrix A equal to np dot array. Okay, and okay, so first row is 23, 14. Second row is 37, 28. Okay, how to calculate determinant? To calculate determinant, okay, we need to call linear algebra. Okay, to call linear algebra module, which is in the NumPy package. So I want to find determinant, right? So I'm going to say det A equal to np dot, okay, linear algebra, okay, dot det. Okay, so determinant, and then you pass a matrix here. You print det A. Okay, the answer is 126. You can do on calculator and check. 23 into 28 minus 14 into 37. Okay, answer is 126. The determinant is one single number that can represent your matrix. Okay, I want to find inverse. Okay, what is inverse of 5?
1 by 5.
Yes. Inverse of 10?
1 by 10.
And inverse of 1 by 50?
15.
I mean, yeah. So inverse is when you multiply that by 1. So if it is on the left side, when you take it to the right side, right? So it goes as division, right? Divided by. So now I want to find the inverse of a matrix. Okay, when you move to the right side, then what happens? To find inverse, what is inverse of 0?
0. Well, infinite.
Right? So yeah. So inverse of 0 is not possible. Okay, inverse of 0 is not possible. Okay. So to find inverse, we again have a function called inv. So you can say inv b inverse equal to np dot linear, okay, dot inv. You say a. Now you print inv b. Okay, so this is inverse matrix of A here. I'm doing it for 2. You can do it for multiple values. Okay, you can do it for 3 by 3, 4, or for any matrix. You see, so this is 0.22 minus 0.11. Okay, so advantage is this. What's the use of inverse? So when you multiply np dot matmul, okay, A comma inv A, inv B, right? I said B, sorry. Okay, A comma inv B. Okay, so what you get? You get identity matrix. So this is
Why
what?
minus sign, sir?
Where minus sign? What does e power minus 16 mean?
There's a above matrix. When we are printing the inverse matrix,
Inverse will have minus sign here. Value is minus. Why can't we have minus?
there is no negative value, no, sir.
Inverse does not mean minus. Inverse is not 1 by inverse. Okay, inverse of matrix we are calculating. We are not calculating inverse of 5.
Okay.
Inverse
Okay.
of matrix can have minus. Okay.
Okay.
See, what does inverse means?
Yes.
See,
Yes.
inverse of 5 means, okay, that if you multiply that number with 5, answer should become 1. Okay. So inverse of x is 1 by inverse, because if you multiply a value into inverse of value, answer will become 1.
Okay.
So when I say inverse of matrix A, we are trying to find a matrix B with which if you multiply A, answer will be 1. So see, we got identity matrix here. So we found inverse B, right? And when you multiply A and inverse B, you got, this is 1 and this is 0, isn't it? 1.6 divided by 1 power minus 16. That means 0.000, 15 zeros and 1, almost 0. And 0 and 1, right? So you see, 1, 0, 0, 1. That's the identity matrix. Okay? Identity matrix will always have determinant 1. Okay? Identity matrix will always have determinant 1. And it has only 1 on main diagonal, other rest of the numbers are zeros. So when I found inverse of A, and when I multiply A into B, we got, let's take another example here. And here we'll make such a way that the determinant is 0. So 23 into 28 minus 28 into 23. So if you calculate determinant here, okay, so determinant is 0. Okay, determinant is 0. That's why you cannot calculate identity. It's called singular matrix. Singular matrix means whose determinant is 0. The determinant of a matrix, if it is 0, it is called singular matrix. Okay, by that means matrix. So matrix with 0 determinant is singular matrix. Okay, we'll stop here, guys. Okay, these are the basic. Tomorrow we'll solve. We'll see how to solve linear algebra problems. Okay, using matrix, we'll solve the problem.